This video is for a half-day lesson in Algebra 2, but I want you to be assured it is not half the fun. This is full fun Algebra 2, not half fun. So without further ado, let's check it out. So here's the problem, okay? And I'm going to pose a problem to you, and I want you to stop and really think this through. So I don't want you to just keep watching the video because I'm actually not going to give you the answer to this. This you need to figure out on your own, and you can do it. If the vertex of a parabola is 4, -3, and 6, 5 is a point on the parabola, what is one other point on the parabola, and how do you know? So let's just kind of go through that again and make sure you know what you're being asked to find. The vertex of the parabola is 4, -3. Just remember what the vertex is, what point is that on the parabola, and where is it located? 4, -3. And 6, 5 is another point that is on the parabola. I want you to figure out what is one other point on the parabola, and how do you know that that point is on the parabola? So what I'd like you to do is pause the video, put 10 minutes on the timer, and I will give you a hint, but I want you to work with it for 10 minutes before you take the hint. All right, so here's your hint. If you haven't tried graphing it, try it now. Okay, so if you have spent 10 minutes staring at it, okay, I want you to try to graph it. To give you some inspiration, there is a beautiful grid right there, okay? And you should be able to find the point 4, -3, and you should be able to find the point 6, 5, and I want you to find another point that is on that parabola. Okay, so you need to keep going with that until you feel pretty confident that you have found another point that's on that parabola. Pause the video now if you need to keep working on it. All right, now that you've figured out a point that's on the parabola, now I want you to use the same method, and I want you to try this one. Okay, so you've kind of wrestled with the first one. You have your point that you think is on your parabola, and you're pretty sure it's there. Okay, you could give me some kind of explanation for it. So here's the next one. The parabola has a vertex of -1, 5, and it goes through the point 3, -3. Find another point on the parabola. So now that you've done it once, you're going to replicate the process with just some different numbers. Pause the video now and make sure that you have another point that is on your parabola. And you can check your answer here. Okay, and so you can check that out. Okay, you can pause the video here, and you can look at the vertex and look at what you know to be your points on the parabola. Okay, and so that's the first part of this activity, is figuring out if you know the vertex and you know a point that is on the parabola, how can you locate a third point? Now here's why. This video is going to take you through how to do a quadratic regression in Desmos once you know 3 points. If you've done regressions in Desmos before, then this will be partly a review. If this is your first time doing regressions in Desmos, then just know that you can apply this to other function families as well. Over here on the left where you see the plus sign, if you click on that, it will give you the option to add an item. And in this case, we are going to add a table. That's going to allow us to plot the points that we know are on our function or on our graph. So for this example, we are going to use the points -1, 5, 3, -3, and 7, 5. And you can see over here that Desmos plots those as I enter them into the table. Now, if it turns out that you have points that you can't see because the numbers are too big or too small, you can always click on that zoom fit. And you'll notice that when I did that, it actually adjusted my viewing window so that I could see the points a little bit better. So that's really, really valuable if you have points that are really big or really small and they're not on the regular coordinate plane that you have there. Now, to do the regression, we're going to click into the second line here. And as with other regressions, we are going to use not X and Y, but we're going to use X1 and Y1. And the reason for that is we want to tell Desmos to reference the table. And the table is labeled X1 and Y1, and Desmos needs to know that that's what we want it to look at. So we'll start by doing a standard form regression. So standard form is y equals ax squared plus bx plus c. So I'll say that again, just so you can kind of catch up. It's y equals ax squared plus bx plus c. Now, in order to do the regression, though, we don't want to use y. We want to use y1. If you just type y and then the number 1, it will automatically make it a subscript. And it tells you, okay, we are looking at a 3-element list right there. Now, instead of using an equal sign, though, we use the little tilde. You can find that near the number 1 on your computer. Okay, it's a little bit trickier if you're using the app. And I just realized the sky is a beautiful pink out right now. We're expecting a hurricane at the time that I'm recording this video. So I don't know what that means, but the sky is a beautiful shade of pink. Okay, sorry about that digression. So we use the tilde instead of the equal sign, and now we will type in standard form. So we will say a x1. So it's not ax squared, it's ax1, and then we want to square that. I kind of messed that up earlier when I was practicing with this. Plus bx, and again, you want bx1, not just like bx, and then plus c. And what you can see is that we have a beautiful parabola that goes through those points, and we have the numbers that would go in the equation for a, b, and c. So I'm going to take a moment and write that down. So I have a is 1/2, so you would have 1/2 x squared, minus b is -3, so minus 3x plus 1.5. And that's the equation that fits those points. Now, what's really cool about Desmos is that you're not restricted to just standard form. You can do your regression in other forms as well. So, and down here in line 3, we will do a regression from vertex form. Okay, and if you look at the parabola over here, we can see where the vertex is. So hopefully our regression will corroborate that. Vertex form will use y1, then we use the tilde, a, and then vertex form, remember, is x minus h all squared plus k. So x minus h all squared plus k. So I will do not just x minus h, but I need x1 minus h. And then we need that squared. And then plus k. And it will tell us what the h and the k values are. Now, one thing that you want to notice, before I had this regression on here, I can actually hide that by clicking on it. The parabola was green, and then when we graphed the black one, notice that it went right on top of the green one, okay? What that means is that they are the same parabola, just two different forms of that equation. And if I scroll down, you can see what those values are. So we once again have a is equal to 1/2, x minus 3, that would be our h, all squared, and then another minus 3. And that's where our vertex is. Okay? And we have one other form of quadratics that we use a lot, and that is factored form. So down here in line 4, we will do the regression with factored form, which if you remember is you have to have the A, again, just because you need to have the room for the compression or the stretch, and then it would be x minus p, x minus q. So we'd be looking for the X intercepts, which are going to be here and here, if you can see where my mouse is, okay? Here and here, not in nice places. So I am expecting some kind of yucky looking decimal for that. Okay. So we will have y1, then the tilde, a, x. Now again, not x minus p, but we need x1 minus p, and then x1 minus q. And if you look at what happened, the red graph went right on top of the black one, which went right on top of the green one. And so what we're dealing with here are 3 different forms of the exact same parabola. And we can look down there, and as predicted, well, first of all, notice that the A value is the same in all of these, but as predicted, we got some nasty numbers for our P and our Q. Okay, so this was the Q value, 0.55. Over on the left, it says 55051. This is rounding it to 0.551. And then over here, 5.449. And we see over here, it's 5.44949. And this actually happens a lot where you have, like you can have nice numbers for the vertex, but you'll end up with terrible numbers for your, X intercepts and vice versa. Sometimes you can get, ones that have nice Y intercepts and X intercepts and like a nice vertex too. But all right, and that is the demonstration for how to do the regression for a parabola once you have 3 points using all 3 forms. I hope this video was helpful. Okay, so now that we've gone through that and you've seen the demonstration, here is your task. Try these ones on your own. A parabola has a vertex of 3, 0 and goes through the point -1, 16. Find the equation for this parabola in standard form, vertex form, and factored form. Don't just give me the A, B, C, H, K, P, Q, okay? I want it actually written in the correct form so that you can use Desmos to figure out what those numbers are going to be. For the second problem, we'll change it up a bit. Suppose the parabola goes through -1, 3, 1, -5, and -6, -12. Now that you know those 3 points, use Desmos to figure out the vertex and figure out the X intercepts. So that would be your task. I hope this video was all the fun that it promised it would be, and that you have an interesting challenge to take on in these problems.